So it looks like for today it'll just be the three of us. So we won't spend much time. Like I said, I just wanted to kind of introduce the course and just kind of help you understand what the plan is for this. Like I said, with a smaller group like this, hopefully we can have more discussion and not just be me talking the whole time. Because I mean, I like to talk, but at the same time, I also want to hear your thoughts as well. So hopefully you have some fun with this course and you learn something. One of the things, I guess, I'll introduce myself and why this course is kind of important to me. Is so my background is actually my bachelor's degree was an electrical engineering degree, and then my master's was it was in America, it was computer engineering, but computer engineering in America doesn't deal with software a lot. We don't deal with programming. What we work with more is about the computer components, so more about like developing electronics and stuff like that. So that was my educational background. Those were my two degrees when I graduated. And the first job that I found after graduating with my master's degree was actually with a software development company, but they hired me because I wasn't a programmer. They hired me specifically to do the testing of their software product. And so I'll probably have a lot of stories from that time. But what they wanted was they wanted someone who wasn't a programmer who would test the software that was a way that a programmer wouldn't test. And basically, one of the big problems in software development is if programmers are the only ones testing, we test with an understanding of what the code is, or at least how the code's supposed to work. And so a lot of times we miss stuff. And what ends up happening is they end up finding problems. So one of the examples I often use is if you're running a Windows or Mac, not so much Linux, but if you run Windows or Mac, oftentimes you'll get a notification, right, that says a new patch has been pushed to your computer and it has to restart, right? And the reason why patches get developed, the reason why patches have to get pushed out is because things weren't right when the product left. When the product was first deployed, things weren't quite right. Some of those things they didn't know about because they hadn't tested those things. And what happened was they were found by users. Users reported them. I'm sure you've also had that experience where a program crashes or something weird happens, and it comes up with a message saying, "Do you want to report this?" Right? You want to report this to Microsoft. And what happens if you click yes? It sends Microsoft some information, and a lot of times that stuff ends up getting fixed, and it becomes a patch that gets pushed to your computer. So for me, I love testing. It was my first job. I love the need for it, but as programmers, we don't like doing it. We don't like testing. We like writing code. Testing seems kind of this extra thing that we shouldn't have to do. So we'll talk about some of the testing and some of why testing is just one part of ensuring software quality. I'm sure you guys have both taken the software engineering course that Umid Hoja teaches.
Which course you mentioned?
So it's a software engineering. I think Umid Ulusar teaches that. Umid Hoja.
In bachelor's, I was in a different university, so. But I took software principles and I took design patterns, and also there was software engineering, but it was quite related, not that much, but they showed us a little things about software testing.
Okay.
For me.
Yeah, no problem. So one aspect of software engineering is this whole idea of a software process. That there are different types of process, and we won't get deep into that in this course because that's kind of like they overlap some, but yeah, they overlap a little, but not enough for me to cover that in depth in this course. So but one of the things is that software process, one of the processes that you maybe a lot of programmers are most familiar with without realizing is what's called an ad hoc process. Ad hoc is basically what first-year programming students do. Is they're given an assignment, they're given a program they need to write, so they sit down at the computer and they just start typing. And then they start typing, they try to run the code, it has problems, they fix the problems, and they keep writing and running until the problems are no longer there and the code looks like it kind of does what it's supposed to do. It's the simplest process to put into place because it is just kind of simple. You just sit down and start typing. But it's also one of the most time-consuming and most costly in the long run because a lot of errors happen, a lot of errors don't get caught, and then a lot of problems end up coming out later that cost the company or the developer time and money. So, but anyway, so this is part of software process. So just like process, you may hear about, we're going to talk about requirements and design and coding and testing. Software quality assurance is more than just the testing part. Software quality assurance is making sure that throughout the whole process that we are doing things along the way to make sure that the final product really is what it's supposed to be. Okay. All right. So as far as this course is concerned, though, let's go ahead and I'm gonna share the slides, share the course information, and then an introduction. And like I said, we'll call it a day after that. All right. So this, we don't really have a room. There's no room assigned to this course. I guess the Microsoft Teams meeting room we could put on there. But you know, this group is small enough. I'm not, are all of you in Antalya or are you somewhere else?
I'm not in Antalya.
So we'll meet online. So my office hours, what I said was, okay, I didn't hear it. I'm telling you, good. So what was I saying? Oh, so my office hours are Wednesdays from 12 to 2. I say I have office hours. What that means in this scenario, I do plan to be in the office during that time, but what it really means is I'm available. Like, you know that I don't have, I'm not going to schedule like a doctor's appointment. I'm not going to schedule another meeting or anything like that during those 2 hours. So if you try to call me on Teams or get in touch with me some other way, I will be available during those 2 hours. If that doesn't work for you for some reason, just make an appointment and we'll figure it out. Okay. This is basically just, I'm sorry?
Thank you very much for that.
Okay. Yeah, I understand that. So you're not in Antalya, so it's going to be kind of, you wouldn't want to come to my office, right? So, but you know I'll be available during that time. All right. So this just is taken from the syllabus. So it's basically an idea of what this course is supposed to be about and what you can be expected to do. Not an exhaustive list, but this is to me a good idea of what you can expect to be able to do on the end of this course. All right. This textbook is what I'm going to be pulling the slides from. The core information from the slides will be coming from this textbook in various forms. I wouldn't expect you to go out and buy this textbook, but if it's something that you'd be interested in, this particular textbook, SQA, testing, that kind of stuff, software quality assurance, it comes from one section of this textbook. So this book would actually be much more useful in a much broader way to lots of software engineering, the processes, the SQA modeling, other major topics as well. So it's not just for quality assurance, but it is a major section of this textbook is about quality assurance, and so that's why I went with it. So you guys are here. You're on the Microsoft Teams, so I don't really need to go through all this. But for those who are not, this is how you need to join this. All right. So this is my idea for how we're going to degrade. I'm not sure if the university is going to have some rules about midterm, how much percentage that has to be, if we have to have a final exam. Right now, I'm not planning on having a written final exam. What I'm planning on doing is having you write a paper and give a presentation, and that will be your final exam. Okay, so you'll give a presentation to the rest of the group, and that will be the equivalent of a final exam. All right, so I'm hoping the university will be okay with that, but we'll find out for sure. All right.
Can I ask you something?
Sure.
So is that paper going to be a scientific format paper?
So it'll be kind of a like a literature review, if you know what that is. So it's like a research paper, kind of looking at recent and important articles. You're going to be. I can give you what I can probably do is share with you one that I did for a similar course, and so you can take a look at kind of what I did. It needs to be something related to software quality. Okay, so I can actually tell you the title of my paper when I went through a similar course was Cultural Effects on Software Quality, where what I did was I looked at how there were a number of particular case studies that looked at people from different cultural backgrounds who worked together, and kind of some of those had really bad results because they weren't able to understand each other's culture, and it wasn't a language issue. They both spoke the same language, but it was some of the cultural distinctions between the two groups. So, so I thought it was interesting, and the reason why I point that out is so my paper wasn't a technical paper necessarily. It wasn't about some new configuration management tool or something like that, but it was more of a kind of maybe like a sociological study of how software development can be affected by sociological things. So yeah, what I'll do is I'll share that that paper with this group, and kind of get an idea of what I did, and then, but I will want you to come up with your own topic and do your own research and present your findings to the class. Okay.
Okay.
All right. So assignments need to be on time. Basically, I don't expect this to be a big problem with this group. So because it's so small. Academic integrity, same thing. Just don't cheat. Don't. I do definitely want you guys to talk with each other outside of class. Talk with me. Talk with each other. Discuss these things. But what I tell all my students is there's a difference where we cross this line between discussing to get a better understanding of something versus trying to claim someone else's work as our own, and that's the line that we can't cross. So, or the other side of it would be giving someone else our work as if it was theirs. So we all just need to do our own stuff. All right, so this is my plan for the time we're going to do this. So today, here we are at the introduction. So you'll learn what all these topics, what all these. I mean, I would say 50% of the words on this page you understand, or maybe some more. But basically, just some ideas of the plan, of the order of how we're going to go through things. Okay. Actually, that should be there. All right. So couple of breaks here, a couple of days that I don't think we'll be able to have class. I think with the holiday on the Thursday, and here, New Year's Day being on a Friday, I think it's going to be difficult for us to have a class those 2 days. So my plan is to break for those two. So make sure you keep up with the course. Ask questions. This is definitely, with a group this small, we can have lots of discussion, lots of interaction. So I definitely want you guys to stop me, especially so English is my native language. So I've been speaking it all my life, and I know that's not true for I don't think anyone in this group is a first a native language English speaker. So as someone who has tried very hard to learn Turkish, I can't imagine trying to take this class in Turkish. And so if I speak too fast, if I speak and I say something that you don't understand, just stop me, okay, and let me know that, and so we can go back over it. Okay, I will not take any offense. I will not have any problem if I say something that's hard to understand, and then you stop me and we go back over it. All right. One final thing on this set is, so I want you guys this week to consider the following questions, kind of maybe even jot down some notes about your thoughts on this. Is how can we be absolutely sure that a system works? And that could be a software system, that could be any system. Okay. How do you define the word quality? What does it mean for something to have quality? What is the goal of testing? And how much time, as a percentage of the overall development time. So you have a system you're developing from start to finish, from requirements to deployment. How much should each of these following tasks, how much percentage time should we be spending on those? Requirements, specification, requirements analysis, design, the implementation, coding, sometimes called the construction phase, testing, and deployment. Like, what should it be? For the 1, 2, 3, 4, 5, 6? Should it be like a sixth on each? Should it be 1% of my time should be done doing testing? That kind of idea. So I want you to think about what you think those, or what do you think about the answers to those 4 listed questions there? Okay. All right. And this you should have access to these slides, I believe, on the Microsoft Teams class materials folder. All right. So just look at it there, and then that way, come back next week and we can talk through it. All right. So what I'm going to do now is going to share introduction. Were there any questions there on that? Any comments? Oh. Okay. All right. We'll get the introduction slides going. All right. So, and I'm going to be tempted to answer some of those questions on that last slide, or at least give my answers for those. So I'm going to have to prevent myself, keep myself from doing that. All right. So here's one of the things. So we have to kind of think through what is it that we want our software to do. What is it that we want our software systems to be able to, like, why do we make them, right? We've made lots of different software products. The human race has made games, has made tools for writing documents, has made tools for doing research. Lots of things have computers in them. Most people don't even realize that there are computers in a car. There's computers in your watch, if you have a wristwatch. There's lots of places. There's a computer in a microwave, right, that helps cook our food, right? So the thing is, though, is like we want to make sure that those things are done well, right? We want to make sure that they are maintainable. For example, that if is if it needs to control a system 20, 30 years from now, we need to make sure that it will still do just as good a job today, hopefully actually better of a job in 20 years than it does today. Right? So we need to make sure that things are, that's kind of the maintainable part of that attribute. And then the dependability, it's not just about does it work. It could also be, is it secure? Is it safe? You know, I mean, if I have a banking software that allows me to transfer money, but it's not secure and it's easy for somebody else to take my money from me, that's not a very good software system. All right. And so, and then efficiency and usability, there's lots of different attributes as well, right? Because we want things to work well. We don't, one of the examples that I think, Aiden, you've been in my courses before, so you've probably heard me use this as an example, that if you pull up a Google search page and you type in some kind of search and you click, you type enter or you click go or whatever, when the result, more than just the results come up, right? So if I were to, for example, let's see if you guys can share my screen and we're going to see this as an example. Okay, let's share. We share the desktop. See the whole thing. All right. So if I pull up a Google search page and I were to say, what can we search? Let's search software quality assurance. All right. So in addition to all of these results, right, the very first thing that we see is this, right? And what is Google trying to tell us? So they don't just put information up there just for the fun of it. They don't just put this information up there because they thought it would be cool, right? They put this up there for a purpose. What do you think it might be? Why do you think they put this information for us?
So I don't have an idea about this.
Okay. Actually, it's very interesting because I think so. I've used this example for many years, and I always kind of focus on this information, but I realize now too that this is also important as well. For it has a meaning as well. But
the ad mean?
Yeah. So is one of the first things that showed up. So it's Google has kind of modified into a trying to make money, right? It's a company, right? So that's why this is second. But this is first, right? This is the very first thing that shows up in terms of even before we get to see any results, right? We see this information, right? Why do you think Google puts that there?
So actually, the first thing comes to mind is that are the other search engines putting this information too? For example, does the Yandex use this? Does DuckDuckGo use this? So is it like showing their customer or their user that we are the better one? Maybe.
Let's see. So Bing.
Yeah, they show that too.
So they show the number of results, but they're not showing. There's something else they're not showing that Google does.
Yes, it's the time.
Yeah. So why is the time important?
It shows how fast it works, but
right.
I don't know why. It's for a user. It's not a recognizable amount of time.
Right. Now to you and me, we say, okay, that's less than a second. That doesn't. Who cares? Like, who cares if it took a full second or if it took a half a second or whatever? But in our minds, speed is still important, right? And what Google is trying to do, one of the things that I think. I mean, obviously, I don't work for them, so I don't know if they've ever had business meetings about this, but they want to be the fastest. They want to say that we are the fastest, that if you use us to search for stuff, other guys might take longer. And in the world that we live in now, where everything is like speed, we have to be the fastest. We have to be the first, right? I don't know if you guys. I don't know if you've kept up with in America, in my home country, we're having an election here in less than a month, and one of the things they're talking about is the possibility that because of the pandemic and because of a lot of other things, that they may not be able to know on election night who won the election. But they may have to wait a few days to count all the votes. And many people are upset that they may have to wait, right? They want to know, President Joe Biden, they want to know that day who is the president. They want to know who the next president's going to be. They don't want to have to wait. And in the same way, we don't want to think that we had to wait longer for our results than somebody else did, right? So anyway, so that's what efficiency is about. So if we think about, pull back up over here. That's what efficiency is about. If you think about that, this type of online learning, if this pandemic had happened when I was in university, or in the late 1990s, in 1997, 98, if this had happened, we would not have been able to do this online live learning. My apartment, when I was in university, we had a 56K modem to connect to the internet. So this type of like video chat would not have been possible because things were much slower. And we live in a day now where things run so much faster. Systems are so much bigger. We don't necessarily think a lot about saving space, about memory space on our computers because we have huge hard drives. I can remember buying a thumb drive, a USB drive for my computer in later on in my university time, and I can remember being so excited that you could fit on a thumb drive, you could fit 256 megabytes of data. All right, 256 megabytes is very small by comparison of what you can fit on a thumb drive today. All right, so everything's gotten bigger. Everything's gotten, in terms of like what it can store, everything's gotten faster, and so we have to be able to keep up with all that. And then we also want our software to be usable. We want users to be able to easily use their software. That doesn't necessarily mean that programmers can easily use it. One thing that I think, for me, a lot of programmers we have a hard time with is understanding that users don't necessarily think like us. And so things that might be easy for us might be quite difficult for some of our users. So one thing that we have to try to get away from, though, is this idea that, so there's do you know the idea of a silver bullet in it's werewolf stories? Do you know what that is? Right. So the idea in a werewolf story is that if you shoot a werewolf with a silver bullet, you'll kill him, right? But if you shoot a regular man with a silver bullet, you'll still kill him, right? But if you have just a regular bullet, then you might not kill the werewolf or person that you're trying to kill, right? So the silver bullet idea is one thing, one weapon, but one type of way of doing things, one process that's going to be able to take care of anything, right? That no matter what the problem is, this will solve it. And kind of the problem is that in as software has gotten bigger and faster, as systems have gotten more complex, we don't really have a silver bullet, one way that's definitely going to work. So this is why I mentioned earlier in the lecture, I mentioned earlier in our time about the software process. There's lots of different ways of doing software process, of following phases of software development. And not one is the one way to do a software system. A lot of times it depends on the nature of the system we're trying to develop. So, all right, so some of the ideas of what our characteristics are. Right? So software, crucial element of our science. We can't live without it, right? I remember as a child, and then into my teenage years, we were oftentimes afraid of potential nuclear war, that somebody was going to drop the big bomb, and that was going to end the world, and things like that. Yeah, I really kind of wonder if a lot of our software systems, think about if software systems that control traffic lights, software systems that control airplanes and on the ground, the air traffic controllers and so if all of that were to, if there were a software virus or something that were developed to take all that out, like that could be a huge problem in society, right? That could cause major havoc, right? And so I think software has become so important, right, that we have to make sure it is done well, that it is secure, and that it's been thoroughly tested to make sure that, as well as we can understand, as well as we can be certain it works. People don't necessarily think about it. It's invisible. That means people don't necessarily think about it. It's this really important thing that kind of keeps us going as a society, but yet most people don't even see it or think about it. Most of us probably have friends that don't even realize that, like I have the Klima, the air conditioner on here in this room, that most people don't even think about there's a computer in that air conditioner that's controlling that to make sure that it works. So we don't even think about that, right? So what does software consist of? Like, we have to make sure we understand that. Software, unlike other things, unlike hardware, unlike building products, are developed and engineered, not necessarily manufactured. It's not about, we can make one software package and then distribute it to millions of people. We don't have to make multiple copies of it. All right, not like the old days when you might get on a CD and you had to print the CD and then ship that out. See, software can deteriorate, but it doesn't wear out. It can get older over time. I had a quote in here. No, okay, it's later on in the set of slides. So these are all characteristics of software that are both good, but also remind us that we have to be on guard and make sure that we are doing a good job of adequately developing. Okay. This chart, to me, this graph is probably an important understanding of what we think what we would like to have, but then what actually ends up happening. Okay, so this darker line here represents what's called the idealized curve. The idea is that at the very start of a software development project, we should have lots of failures, right? If we were to test our code, before the system exists, everything should fail, right? If we try to deposit money into a banking system that doesn't exist, it shouldn't accept it, right? So there should be lots of failures as we begin development. But then as we develop over time, it should fail less and less until it basically fails never. Over time, it should eventually just work, right? The problem is that's not really how things end up working in the real world. We do have the starting point where it fails a lot at the beginning because the software has not been adequately developed yet because the system's being worked on. It does fail less and less as we start meeting those requirements, as those requirements start getting put into code and tested and making sure things work well. we start seeing fewer and fewer failures. The problem is that at some point there's going to be some type of change. The customer is going to say, I don't like this, the way it does this. Can we change that? Or there will be some new feature they want to add or something like that. I mean, if you've ever owned a smartphone and you got a new OS for it, you know, there's always changes, right? Things look different. Things operate differently. I personally have an iPhone, and so I know that there are certain apps that run on my phone that don't run on my wife's phone because she has an older version, right? Or her apps are different. You know, they're a different older version of the app. So there's a change, right, that wants to happen. The thing is that when a change happens, it means that right now the software does not meet the requirements that we had. So suddenly there's lots more failures we have to deal with because this isn't right anymore. There's lots of things that don't work right. So we have this jump up, right, in the failure rate. Okay, so we start working on that again and again and again, and nope, new change comes in, new change, and we keep kind of doing that until now. Why does this curve never kind of reach down here? And some of it is because as not only are the changes increasing our failure rates because we don't have those changes met before, because we don't develop for changes before we know about the changes, right? But another big part of it is that even stuff like the OS that the software is running on, the language that the software is written in, stuff like that, has become, over this time, has become less secure, right? People with ill intent, like hackers and stuff. Oh, you know what? The headphones are starting to go out. Let me finish this statement and then I'll switch off of these. So like hackers have figured out how to take advantage of the OS or how to break into security vulnerabilities of the language that was used and stuff like that. And so that also increases over time our failure rate because it makes the software itself less secure in the language, the basis of what it's used. All right, let me real quick turn off. Right. You guys should hear me on.
We can hear you.
You can hear me on the. Okay. All right. So now I'm on the microphone and the speaker, so hopefully that won't cause problems. All right. That was more of a test on the microphone and the headphones anyway. All right. So yeah, so I love this graph because oftentimes we have this idea of that's how it should happen. This is how it should work. But in real life, in the actual how this plays out, it becomes quite different. Okay. I will probably talk to you guys a lot about my industry experience over the next few months that we're together. And I have seen this play out time and time again. And especially the types of changes that we allow as software developers, as a software developing company, that will drastically affect our ability to get closer to this line. For example, that company that I told you about, the first one I worked for as a tester, one of the allowed reasons for the customer not accepting the product was, I don't really feel good about it. Well, what do you mean? Does it not? We would say, what do you mean? Does it not adhere to the requirements? Oh no, it follows the requirements, but I don't feel right about it. Well, that's not really a reason for failure, now is it? But if you allow that, if your company allows the customer to have I don't feel right as being a reason for failure, guess what? That increases your failure rate. All right, that's just automatically going to increase your failure rate. All right. Here's some differences in, again, how software has changed over the years. All right, software a lot of times ran on a single processor or a mainframe. If you've ever heard of people using a mainframe before, we didn't have to deal with security as much with a mainframe, right?
A mainframe was usually a single large computer in a big room, right? And a room-sized computer in a big room. So really the only security you had to deal with was making sure that you had a guard at the door to make sure that nobody could come in if they weren't supposed to. Right now, everything's connected to the internet. You have Internet of Things, and you have devices connected to this wide network that oftentimes there's lots of possible sources of people being able to get into these devices that aren't supposed to be. Okay, so it's important to understand why our processes for developing quality software need to change with the changing times. Okay? So we can't use the same methods that we used to use to ensure software quality. We need to change with the way things are being done differently. All right. So this compressed time to market idea, basically some of the major reasons for why things have changed. People are not as patient now. I mean, again, we come back to this Google thing, right? You know, you and I might be able to say, well, there's not a big difference between a second or 0.6 seconds, right? But what if this was something that would run, you know, 1,000,000 times, and we're talking about, you know, or maybe not 1,000,000 times. I'm trying to think of the right factor. Okay, I don't know what, you know, but basically the idea of what I'm getting at is, what if the difference was the difference between half of an hour versus a full hour? You know, what if it was something that ran thousands of times, each of them being 0.6 seconds or 1 full second, and when you add them all together, you end up with an hour versus a half an hour. And that makes a bigger difference, doesn't it? Yeah. And so so people want to make sure that when we say the product will be out on such and such a day, that it actually is put out there. All right. So I'm trying to think of what other things I want to point out here. Right. So there's this expectation of sophisticated user interfaces. So one of the other classes that I'm teaching this semester is the system administration course, and a lot of it is heavy on using the command line to be able to do things. Most of our students, most of our undergraduate students, have never looked at the command line before. They've all used user interfaces. They've all you know, used Windows, or, and I don't mean Windows like the operating system. I mean like used like GUI windows with the mouse to be able to get stuff done, right? So the more and more that people expect there to be a well-made user interface, something that looks sleek, something that looks usable, right? And so that means that time has to be spent to develop that, because sometimes the software itself may be great, well-designed, wonderful. But if it comes with a clunky looking, kind of weird looking GUI, the users are not going to think that it is good, and they may not continue to use us, right? So we have to kind of be able to have this balancing act. All right. All right. Some problems, right? Many critical systems are controlled or influenced by legacy software. This is especially true in government systems, like worldwide government systems. I can tell you, I had an experience of trying to work on trying to upgrade a legacy system that had been produced by a government agency. It was written in COBOL. I don't know if either one of you have any of you heard of COBOL?
Only as a name.
Yeah, right. So COBOL is it's like an ancient language, so I tried to learn it. I still haven't learned it because basically we lost that customer before I was even able to get too much involved in the project. All right. So the thing is, though, is the programmers that at the time, the programmers who were working on that system were all in their late 50s and early 60s years old. Well, I don't know about the retirement age here in Turkey, but in America, the considered retirement age is around age 65. And so basically what the reason why they were trying to get me to learn COBOL was because I was young at the time, not like today. But what they wanted was they wanted somebody who could continue maintaining the project, right? Well, the problem was that meant requiring me to learn a whole new programming language, a whole nother programming language, simply to maintain this program, all because they didn't want to spend the money to upgrade to a newer technology. They could have upgraded to any of a number of languages that was newer, Java, C++, lots of different possibilities for upgrading that project, but they didn't want to spend the money to do that, and so instead they continued using the old system, right? Okay, so that's one big problem is these older systems, these old large systems that many of them control very important things. I mean, yeah, you think government systems are going to control lots of important things, right? And so we have to try to maintain them, and if they're not understandable or irreplaceable, then that could cause major problems. Okay. One of the questions I asked you was how you define quality. It is difficult to define and measure. That's why I wanted to see what you thought. And so I want you guys to come back to class, come back to I don't want to call this a class. I want to call this discussion time. I don't know. But I want you to come with ideas of what you think it means for software or anything for that matter to have quality. All right. Software doesn't have spare parts. It's not like a car that if the battery dies, you put in a new battery, right? Software doesn't have that. You can't say, oh, well, that variable stopped working. Let me put a new variable into that code. That's not how it works, right? Software project managers can be sometimes far removed from software development. They're not involved. Like I would say, in my 10 years of software development, actually I can't, 3 of my years I had software developers as managers, but I would say I spent a 4-year period where my direct manager on the project I was working on had a business degree. They did not have any software experience at all. So every time that they asked me for status reports and had me try to explain what the software was doing, a lot of times they didn't know what I was talking about, and they just took my word for it that it was working well. Well, what happens if our software developer doesn't really understand some things, but they're explaining it to someone who equally doesn't understand some things? Well, that can cause some big problems down the road. All right. Again, software developers are sometimes unaware of engineering approaches. I would say I was 6 years into my 10 years of being a software developer before I even found out what a software process was. And it was through a class that I took online, right? So this idea of having a systematic approach to developing software, didn't even know it existed. All right. So sometimes many myths pervade the software development culture. Again, part of the problem is, like, especially if our manager is not a software development, there's an old joke that technology, and especially software, to anyone who doesn't understand it, it looks a lot like magic, right? We do things, we make the computer do things, and you probably have family members that think this is just amazing and magical, and I have no clue how to do that. And so a lot of times they think that anything can be done because you're a magician or because we are magicians. Story, when I was an intern I worked for a company that did RF devices, radio frequency devices. I worked in the I worked on both sides of that, but it was an internship. And I remember one day our project manager came in, and I mean, he was just angry. He was just angry. And apparently a customer had a meeting with the CEO, and this was a smaller company. It's only about like a couple of dozen employees. And the CEO had a meeting with a customer, and the customer said, "Oh, well, can you make the product do this?" And the CEO said, "Yeah, we can do that, no problem. And our deadline is 2 months from now." And the project manager came in, the one that was really angry, and he said basically he just promised them technology that doesn't exist, so we have to invent technology that doesn't exist, and we have 2 months to do it in. All right, and so that's the idea, though. The CEO did not understand technology enough to know that that didn't exist, nor did he understand that it wouldn't be possible for us to create this new technology in 2 months' time, right? And so, but the myth is, well, you guys know technology, so you can make anything happen, right? And so that's one of the myths that we have to overcome, right, in software development. Okay. This was an example. This was a quote that I saw in there that reminded me of my own COBOL experience, right? So some of the key points I want to say here is this guy, this nuclear scientist, ran across codes and methods and functions that are more than 40 years old, and the guys who wrote them have passed on, are no longer alive, right? Nobody knows what the original programmer was trying to do, so comment your code. All right. To figure out, we had to read the code in Fortran line by line. So if you don't know Fortran now, guess what? You have to learn Fortran in order to understand the code. All right, and try to understand what's going on and to understand the code, to even just maintain it. Right. This is a funny ending point to this text. Once someone found a bug in the code, removed it, but then the code wouldn't work. So they put the bug back in, even though no one knew why the program worked that way. All right. So I've seen that happen actually with our students, with our 101 students, where there are times where they put a line of code in there. I will ask them, hey, why did you put this line? I don't know. It wouldn't run without that line, but I put that line in and it started working, and I don't know why. All right. And it doesn't look like it's anything that actually affects their program to me. Right, but for some reason, when the line is removed, it stops working. When the line is put in, it starts. Yeah. So that's the kind of stuff that we don't want to see, right? We don't want to have bugs that we don't know why they have to be there in order for the code to work. Right. Here are some other myths. I don't want to go too much in depth of all this, but this one, right? A general statement of objectives is enough to get going. Fill in the details later. This is a first-year student idea, right? This is how a first-year student programmer will do this. I have an assignment description. I'll just start coding, and I'll make it work. All right. Okay. Once the program is developed, tested, and delivered, the developer's job is done. Nothing could be further from the truth, right? That just because something is delivered doesn't mean there isn't stuff that's not working. We just don't know about it yet. All right. Let's see. These two together, right? We can always add more programmers if the project gets behind. All programmers are created equal. I want to ask you guys, do you know about, I can't remember, it's something.gov. It was the Affordable Care Act. It was also called Obamacare. Have you ever heard of that? It's an American healthcare thing. No? Okay, so I'll have to find a paper on it because it was such an interesting thing. So when President Obama was president of the United States, one of the bills that they pushed through was getting affordable health care for all Americans. The healthcare system is different there. Insurance is done differently. Well, the day that the rollout of the website for people to sign up for healthcare, for health insurance, the day that it was the deadline, it was fast approaching and the system wasn't ready yet. Well, the day that it came, the day that it went live, the day that the website went live, it crashed. Lots of problems happened. Well, one of the things that came out in the news was that they knew they were going to be, the deadline was not going to be reached. They knew about a month prior that the deadline was not going to be reached. What they did to help the deadline get reached was they hired like dozens of new programmers to come and join the project, thinking if we add more programmers, the project will be done faster. Okay. The problem is that software development is not like building a building, right? If let's say my apartment building, let's say it's not ready, it needs to be ready in half the time that we currently are able. Let's hire some more construction workers and make the construction project go faster. That will probably work for the most part. Because construction, I don't have to train you necessarily how to lay bricks if you're a bricklayer. I don't need to train you so much about how to plaster or paint walls if you're a plasterer or a painter, right? But a programmer, there's time that we need to train you how the system works, right? We need to train you on things. It's not like we can't, if I were to say, I don't know, if I were to say, I want to add you to some new system as a programmer tomorrow, you know, it's in Python and you're a programmer, you know a little Python, I can throw you on a project tomorrow and you can start working on the project tomorrow. That would be kind of, you wouldn't be able to start coding tomorrow, I'm assuming, right? You would need to first know what the project is, right? And so, but the idea, the myth is we throw more programmers, we'll get the project done faster. In actuality, statistically, according to the studies that have been done, the more new programmers you add, the more delayed the project actually becomes, right? And so that is not to say they should have fired programmers in order to get it done faster, but that's not going to happen. But there is this idea that if we add more people, we get things done faster. And software development is not the same as other types of construction and other types of development. So these are all different parts of software engineering. Like I said, I don't want to get too much into software engineering. I do include these slides so that you can have some ideas of how software quality fits with software engineering and some of what are the importance of that. At the basis is a focus, a focus on quality is how we develop our process or what process we choose to use. What's our methodology for software development? What tools do we use? All this kind of builds on itself. But if we don't have this foundation of a focus on we want to develop quality software, we want to make sure we do everything that's required to make this system a quality product, then all the rest of this just doesn't really matter as much. All right. Okay. So again, software quality is a part of the whole software engineering. These are some different principles that are in the idea of software engineering. I don't want to get too much into this because again, but I do want you to understand that these are some key ideas involved in the field of software engineering. Okay. And since I don't want to get too much into that, I do want to include these slides so you can take a look at them yourself. But like I said, I don't want to do too much in this first day because I just kind of want to introduce what the plan is for how this course is going to be done and how it's going to be run. But yeah, but I encourage you to look more into these 8 bullet points here are all kind of expanded further in the next slides after that. So take a look at those, to have an understanding of what software engineering is all about. I'll go ahead and pull back and stop sharing, and we're back to us again. So I want you to go ahead, like I said, think about those questions that are on the last slide of the not the introduction slide, what do I call it? Course information slide. Okay. take a look at those questions. Come back next week for us to be able to discuss those together. All right, because I'd like to hear what your ideas are for what you think about how can we ensure systems work and what is quality. All right. So is there any questions? Have you ever thought about software quality before?
Well, I did, but there's an echo between the sound.
What's that now?
There's echo. I'm hearing my.
Yeah, I think it's because I'm not on the headphones, and so it's messing stuff up. So here, wait, I can't mute you. Maybe mute my mic and you talk.
Okay, now I can talk. While you're hearing yourself, it's really hard for my brain to speak. Okay, so I've been working in game industry in the last year, and my biggest passion is about video games most of the time. So I try creating them. While doing video games, we are having lots and lots of bugs, and also the games are prone to change. So like you can add new meta to your game, for example, balance your character's abilities or stuff like that, and you can always update your game. You can add more levels and more stuff like that. So I have been thinking about this for a lot while doing video games. So to me, software quality is mostly about flexibility, in my opinion. Being flexible in a project is very, very important, but I will be thinking about this question this week alone, and the next week I will come up with a longer explanation if I can.
So do you work for a company to develop the games?
I used to, but after beginning for my master's degree, I left the job last year. In last year, I was in a different university and studying game technologies for masters, but the education was not that good, and I know a few lecturers from Akdeniz University, and I switched to here this year. As a hobby, I'm creating my indie games, and I'm keeping up. I'm doing some freelances, but for now, I'm not working. I'm focusing on my master's degree.
Okay. Did your company have any kind of software process or like do they have like phases of development, like requirements, design, implement, like and testing and all that?
So the game companies that I saw in Turkey, I worked in one, and I did a few jobs in some others, but not for a long term. But it's not like that. They're not aware. They don't even think about this. I actually took a game metrics course, which was somehow related to this one also last year. So in Turkey, no, companies are like they are doing 2 or 3 games in a week, which are very low quality, which they call as hyper casual, and they send it to the publishers. So if it gets a good rating from the publisher, they put ads on it and they publish it. So it was not, and all the games were full of bugs, and they were like the code were not robust, and they weren't optimized to run well on both mobile devices and PCs. So it was a disaster, but it is how the companies are working in Turkey for now. But for AAA games, for games which have big budget, big time, and big, how can I say, big employees, many number of employees, they care about software quality assurance. But I did not have a chance to work on a AAA company.
Cool. Well, thanks, Alper. So, Aydin, did you want to share anything? I actually can't hear him. Can you hear him?
Can you hear me now?
Yep, now I can hear you.
Yes.
Yeah, as our friend says that sometimes some big companies like, for example, Ubisoft in America just wants to, make a software, make game to earn money, and they really don't care about, fixing the bugs. Fixing the some server problems. I can say it's these are all the problems about software quality, and if we to make a software, we should care about this. To being not sometimes down in server sections, and I can say this is my idea about software quality. But as user idea, we should make a software that it's really I can say easy to use and not that much complicated, and with having a very good interface. And this is the software quality which it's in my mind.
All right. Well, thank you guys so much for taking the time to be here on this call today, and we'll go ahead. Like I said, we'll end early. So that's all I really wanted to do. I just want to kind of introduce the ideas of the course, and to help you understand that, again, for me, when I was a student, the way that we developed software as a student was we sat down at the computer and we started typing. And then I get out into the companies, and a lot of companies do the same thing. A lot of companies, that's kind of, they don't think about the plan to how to develop software well. And what we'll see as we see it, some of the statistics and some of the papers that I'll have you read and stuff, is how we need to be able to, in the growing field of what software development is, that we have to be able to come up with more intentional ways of making sure that we develop good software that meets the customer's needs and that does what it's supposed to do. So, all right. Thank you guys. I'll end the recording here, and then that way the other two students who weren't able to join us today can see what we talked about.
I